Hello, welcome to this tutorial sheet walkthrough of question 2 on sheet 4 for ME4111 Engine Mechanics 1 Statics at the University of Limerick. So what we're looking at here is a pipe assembly that has a couple acting on it. So we're told this in the question that we got this couple acting, and we're asked to express this in vector form. So we can see here from the answer that we're looking for the moment of this couple to be expressed in terms of its I hat and J hat. And if you look at the answer, you can see that it's just got an I hat and J hat. It doesn't have a K hat term in it. And that's because the direction of F is in the Z direction and minus F is in the negative Z direction. So this couple has no rotation influence about the Z axis. It only has it about the X axis and the Y axis. So our solution to this, excuse me, is quite straightforward. What we're going to do is we're going to just do it by inspection, looking in from the x-axis and looking in from the y-axis. So if we look in for the x-axis, we look at how this couple causes a rotation about the x-axis. So the first thing we do is that we write down the magnitude. So we have 25. We have our I hat, which means we're taking about the x-axis. And our spacing here is down as 0.4 minus 0.2. Okay, so this is our 0.4 and this is our 0.2. We've changed that into meters. So we're getting then is this distance between the lines of action of the two forces, just looking in from the x-axis. Okay, our direction here is determined from looking at how this rotates. And if you imagine this thing spinning about the x-axis, it would cause a clockwise rotation, which in our convention using the right-hand rule gives us a minus sign on that. Then we repeat this process for the y direction. So we look in from the y-axis and we look at how these two forces that are acting as a couple cause a rotation about the y-axis. So again, we have the magnitude. So we got our 25 here, the magnitude of our force. And then our distance now is the distance between these two. So it is the 0.15, which is here. That corresponds to this here. And then the 200 is from here. Okay, so we've got 0.35 as a spacing between the lines of action of these forces when we look in from the y-axis. And the plus sign that I've assigned onto it is coming from the anti-clockwise rotation caused by this. So if you look at this from the y-axis, it will cause an anti-clockwise rotation, and that gives us a positive moment due to our convention. So we multiply that out, we end up with the minus 0.5 I and the plus 8.75 J hat Newton meters. So our answer therefore is, again, this is important, that the resultant is 0 because these two forces cancel each other out. And our moment then is minus 5 I hat plus 8.75 J hat Newton meters. Okay, thank you for listening. That was a quick one, and we'll see you for the next one.